elastic region and this plastic region. What's actually happening when a material is in this elastic region or in this plastic region? So this is our next vocabulary word, and that's plastic or plasticity. Plasticity is the noun. That's how much plastic ability does it have. Plastic is an adjective. Wow, look how plastic that thing is. And here's the textbook version. The textbook version is the ability to deform, again, which is strain. Strain is to change length or change size without breaking. So if something, if you squish something or you stretch something, and it moves but doesn't break, and then we say that it has a large amount or some amount of plasticity. It's acting very plastic. So a lot of materials that act plastic, or a lot of materials that have plasticity, happen to be polymers. So in this case, in the camera here, my shirt, the cotton of my shirt is actually a polymer. I wouldn't necessarily say I'm wearing a plastic shirt, but if I was wearing a synthetic polymer shirt, say for instance the synthetic polymer that's on my microphone boom here, this thing also stretches. You can see that it's moving as it is not breaking. This guy is a polymer, my shirt is a polymer, my skin is a polymer, and they're all exhibiting plastic behavior. When I push on them, they happen to move or squish or flop around, but they don't snap. Thank goodness my face doesn't snap when I move it around. So they're exhibiting plastic behavior. So sometimes we nickname this polymer material, hey, can you grab me that plastic? Or, well, that was pretty inexpensive. What was it made out of? Oh, it was made out of plastic. So when we use plastic this semester, we're going to be using it as an adjective to talk about any material that sort of gives before it snaps off. And then the noun, of course, is plasticity. So here's an example of a very, very plastic material, and that's Play-Doh. So Play-Doh is this material here. We've all played with it. There's a rolling pin, and the Play-Doh sort of moves out of the way. It's sort of like clay. It's very plastic and changes its shape by just pushing on it. And unless it tears, it doesn't really snap off or break. I guess maybe if it's really cold or dry. Very close related to that is elastic or elasticity. Again, elasticity is the noun, and that's the ability or the capacity to have the adjective elastic. And again, here's the textbook. It's the ability to take original form after straining. So back here, we talked about the ability to deform or change its form without breaking. Down here, we have the ability to go back to the original form after it has deformed or after it has been strained. The typical example is a rubber band. We take this rubber band, we stretch it out, and then it snaps back, or we can very slowly put it back. That is an elastic property, or it's displaying elasticity. So different materials are elastic. Not all materials are elastic. Not all materials are plastic. Not all materials have plasticity. But if you have a material that exhibits plasticity, which is this rubber band, and it happens to go back where it came from, then we say not only is it plastic, not only is it exhibiting plasticity and stretching without breaking or snapping, it's also going back where it was. So the elastic and plastic, keep on saying this until it doesn't sound good, elastic and plastic are very, very closely related, but they do mean different things. So if we go back here to our stress versus strain measurement, and you'll notice right here again, vocabulary-wise, we have the adjective elastic region, and up here, plastic region. What they're saying is, if this happens to be the cartoon, or the data actually, of this material, as we apply a force per unit area, we stressed a material, and it starts to strain. It gets longer or shorter compared to what it was originally as we continue to stretch it. In this blue region where it says it's the elastic region, this is where it has been measured to snap back where it came from. So in this case, that rubber band we had, if we were able to stretch it with this force per unit area and stress it or stretch it or strain it over this distance, as long as we stayed in this blue area, it would take a lot more force to continue to stretch it further and further and further and further. If we let it go, it would come back to where it was. This is still the elastic region. After you stretch a material or compress a material like a spring beyond its elastic region, then you're just, making it longer permanently. And of course, that's called the plastic region. It's still stretching. If you imagine me taking that elastic band and stretching it so far that it doesn't come back. What we're doing is we're just stretching it and in the plastic region. We're past the elastic; it won't come back. We're permanently deforming it, and then eventually we will continue to stretch it until we fracture it. Okay. I'm not chewing gum at the moment, but if not a spring, if not a rubber band, let me go back and do this in its amazing glory. Go back to my big picture here. If I pantomime having chewed gum in my mouth, if I take my gum and stretch it a little bit and then it comes back to the same size, that's the elastic region. But if I were to take some gum and stretch it all the way out here and then it snapped in the middle, what would happen is eventually it just got really, really long. It went through the elastic, it went through the plastic, and then it fractured and it fell. So my chewing gum, when it's being chewed, if you stretch it a little bit, sort of like when you blow a bubble, that's the elastic region. If you stretch it a lot of bit and it doesn't come back, that's the plastic region. And if you stretch it so far that it snaps, that's fracture, of course. Let me push back this guy over here. So thankfully, I'm sure you're happy that I didn't actually put bubble gum in my mouth and get it all over my keyboard.